the topic, our topic is the research on the task schedule structure based on the trustworthiness of the MapReduce. The outline is include introduction, reliability task schedule strategy with the introduction of the failure recovery mechanism, reliability task scheduling algorithms introducing failure recovery mechanism, simulation and conclusion. So first things is an introduction. Aiming at the shortcoming of the fault-tolerant technology in the MapReduce programming model, our paper proposed a reliability task schedule strategy with the failure recovery mechanism, evaluate the trustworthiness of the resources node in the cloud environment, establish the trustworthiness model, and avoid task allocation to the low reliability node, causing the task to be re-executed, wasting time and resources. Then, the simulation platform CloudSim verifies the validity and stability of the task schedule algorithms and the scheduling model proposed in this paper. So this paper makes some following assumptions about the cloud environment platform. The first is the cloud environment platform is heterogeneous. The second is our model in the heterogeneous platform has and only have the two work status, normal operating system and failure status. When a node fails, it is in a valued state. The third is the failure status of any node has nothing to do with the other node and will not affect the other nodes in the normal state. The fourth is if a node is in either status, when it fails, the node will be replaced by another node in the standby status, which does not affect the schedulability of the task. If there are tasks that are being executed on the failed node, the failure recovery mechanism and the replacement mechanism will be used to ensure that the node is restored in a normal operation state. So the second is the trustworthiness is a parameter to evaluate the reliability of the system or product. Reliability means that the certain system or the product in the trustworthy or the no trustworthy. Usually trustworthy metrics are as follows: trustworthiness, then failure rate, then mean time to failure, then mean time between failures, mean time to reply. The task schedule strategy that aims at maximizing the reliability of the task schedule of the minimizing the total response time of the task in a common task schedule model in a cloud environment. So in order to improve the parallelism of the application, the job of the often divided into the multiplied task and executed in the parallel on the multiplied node at the same time. A task executes on only one node. When all tasks return to the task execution result, it indicates that the job is successful, complete. Assuming the NJ is the set of the node performing the task, the reliability of the task can be expressed as the form In order to maximize the reliability of the schedule strategy and minimizing the total response time of the task, the object function is set as the following formula. Since the value of the total response time of the task is larger than the value range of the reliability, X can be used as a scale factor to coordinate the proportion of reliability and time cost to prevent the time cost from the controlling the objective function values. The reliability task scheduling algorithms introduced failure recovery mechanism. Arming the task scheduling problem in the cloud environment, the trust evaluation model consider the failure recovery mechanism is introduced into the anti-column simulations and linear algorithms. And the anti-colony simulations and linear algorithms considering the failure recovery mechanism is proposed. This paper proposed anti-column algorithms ACOSA based on SA. Its principle is to find the local optimize the task scheduling solution for task T and not N through ACO, and then use the SA for the local optimization, thereby assign the task at the appropriate heterogeneous resources node for execution. Among them, ACO set the initial formal concentration to a constant before the end searches, which will increase the end searched space as this formula. With the increased time, the concentration of the formal become high and high, and then the end can choose the appreciate the path according to the concentration of the formal on the path that the end worked last time. When the task is scheduled to be executed on the resources node, the trustworthiness reflects the reliability of the service provided by the target resources node. The ACOSA algorithms fully consider the heterogeneous characters of the source node, but does not consider the impact of the trustworthiness of the source node on the task schedule result. For this reason, we take the maximization of the creatability and minimization of the time cost as the object function and the function as the heuristic function of the ACO. In the actual cloud environment, when a node fails, the task assigned to the node will not be re-executed. The advantage of the introduced failure recovery mechanism is that for these failures that can be recovered, the node can recover the tasks that have the stopped execution by running the failure recovery program. Execution steps based on the reliability task schedule strategy is as follows. The first thing is initialization parameters. The second is construct a feasible solution. The third is update the formal. The fourth thing is SA platform particular optimization. Execution step based on reliability task schedule change is just as the follow. Mature policy guidelines, termination criteria, global formal update. Total are the 7 steps. So we have taken some of the simulation in the wide experience. In the simulation impairment, the influence of the failure recovery mechanism and its parameters on the evolution of the trustworthiness of the resources node is discussed. And the performance of the algorithms is compared in the case of the different node and the number of the tasks. The experiment environment parameters are set as follows, just as the slide. So here give some of the results. The first thing is on the task execution success rate on the difference failure recovery without limited maximum number of the recoveries. Just show in this finger. The second result is in order to study the effect of the failure recovery rate on the task execution time, this article conducted experiments on the 3 different types of the task, and the experimental result as shown as the following figure. The third thing is it can be seen from the following the figure that when the number of the tasks gradually increased, the task execution success rate of the FCFS, the first come first service algorithms, and the ACOSA algorithms is gradually decreasing. But the task execution success rate of the ACOSA algorithms with the introduction of the failure recovery mechanism is significantly higher than the FCFS algorithms. We can show that in this figure. The first result is it can be seen from the following figure that the task completion time of the ACOSA algorithms with the introduction of the failure recovery mechanism is shorter than the task complete time of the FCFS algorithm, which provide that the introduction of the failure recovery mechanism can not only improve the execution success rate of the task, but also select the appropriate failure recovery. So FCFS algorithms with provide that the introduction of the failure recovery mechanism can not only improve the execution success rate of the task, but also select the appropriate failure recovery. The performance of the ACOSA algorithms with the introduction of a failure recovery mechanism mechanism is better than that the FCFS, the first come and the first service algorithms is in the case of the low rate. Just see in this figure. So the conclusion, across the composed of the large number of the resources node in the cloud environment has the characteristic of the heterogeneous, dynamic, and uncertainty. Reliability reference to the probability that a task submitted by the user is successfully completed. In a cloud environment with a large number of resource nodes, node failure events are inevitable. Arming the defects of the MapReduce fault-tolerant mechanism, this paper proposed a reliability task scheduling strategy that introduced a failure recovery mechanism to evaluate the trustworthiness of the resources node in the cloud environment. Establish a trustworthiness model to avoid assigning tasks to the node with a low reliability, causing tasks to be re-executed and wasting time and resources. Finally, we use the simulation platform CloudSim to verifies the validity and stability of the task schedule algorithms and the scheduling model proposed in this paper. So that's all. Thank you.
Thank you very much.